milliamperes. For DC load line, we got the answer as 3 milliamperes. For AC load line, we got the answer as 3.5 milliamperes. So now what we are going to do, we are going to plot these two values in the same graph to draw the AC load line, 21 and 3.5 milliamperes. See the graph. I am plotting 21 and 3.5. So where is 21? See here. 21 is plotted here and 3.5. 21 will come below the maximum of your DC load line. 3.5 will come above the maximum of your DC load line. And you join this line 3.5 and 21, you get what is called as your AC load line. So this line is going to be 24 volt is going to be your DC load line, and the line containing 21 volt is going to be your AC load line. And as we said, both these two lines will meet exactly in one point. That is going to be the operating point of your transistor. So mathematically also you can verify. So if you write the equation for this line, this will definitely pass through this point. And this will not be in the midpoint. When you consider the AC load line, the Q point will not be in the midpoint. The midpoint will work only for DC load line. And your AC load line is very, very steeper compared to your DC load line, right? So the midpoint logic will not work, because 21 by 2 midpoint will be 10.5 and 3.5 by 2 will be 1.75. So it will not be exactly working out for AC load line, because we are more focused about DC load line in a transistor, because DC load line provides the necessary biasing for your transistor. AC load line we draw just to understand how the amplification is going to take place. So before the amplification has to take place, the transistor should be properly biased, right? So all the operating conditions, fixing the Q point, everything is done using DC load line only. AC load line is drawn just to analyze the amplification properties of your BJT. Okay, don't think all the parameters of AC and DC load line will be same. No, they will not be same. There will be slight variation in the voltage and current values what you get in the AC and DC load line. And this midpoint is only applicable for DC load line. Please remember that if you draw the midpoint using AC load line, then your transistor will not be in the active region. It will not be in the active region. Okay, so any doubt in this problem in the part C? Any doubt in the AC load line in this problem? Are things clear? Are things easy for you? Just one equation you have to remember. What is that equation? VCC equal to VCE plus IC into RC. That equation will completely solve the problem in a very simple way. Any doubts? Please feel free to ask any doubts if you have. Don't be silent, and if things are clear, I'm happy. Otherwise, electronic circuits classes cannot be go in silent mode. You have to pester me with lot of doubts. Unless you have clarity, you should not allow me to proceed the